So here mainly in the fabric, one of the important component that is Microsoft Fabric, that now as a Microsoft Fabric notebook simply. So Fabric notebook, it engages your runtime Spark cluster to execute your jobs. Okay.
Runtime Spark Plus.
That means in the serverless mode. Okay.
Yeah, do you have any other option like as similar to Databricks, both you can run
No, no,
less than cluster?
no, no, no.
If I
So
want any GPU kind of workloads, right? Can I run in Fabric or
no, not like that. If it is GCP kind of things, you have
GPU, sir, GPU based.
GPU.
Ah,
GPU is it. But based on the models, what you are triggering depends on that if necessary GPUs, because here the things are called SKUs, capacity units.
okay,
So
SKU
in paid
concept. Okay,
versions, we can take the selective
okay,
rapid runtime missions. Okay.
okay, sir.
So if it is Google, to execute the Spark, they have data proc.
Good data.
Google data proc.
Google.
Within that, you can engage Spark clusters and you can run it.
Okay, sir. Got
Right.
it.
So engage a Spark cluster in runtime. That to here it is a serverless. Serverless mode means you need not to set up any physical cluster.
Physical plus.
Okay. So automatically it depends on the workload. Automatically cluster will be engaged for you. Good morning. ఇలా కూర్చోండి నీకు ఇటు సైడ్ వచ్చేసి. So here one important before do the first lab on the notebook. One trial of the Spark code we do with the collab. Collab. Later I bring that code into this notebook, Fabric notebook. Okay. So first you answer me, what is Spark? Is it a database or is it a file system?
It's in-memory engine that runs in parallel bus.
That means Spark, you remember, Spark is not going to store any data.
Execution.
That is only meant for execution. That means data processing. Okay. So simply what is Spark means, Spark is an execution engine to process data. Understand? Here, whenever you are saying you process means what type of process? Batch process. And also supports streaming data process. Okay. Batch process, streaming data process. So the streaming data process in the style of micro batch. So generally batch process means, suppose example, yesterday night one sales report generated. Again, when the next sales report is required, today night. Yesterday a sales report, today also sales report. The batch job is taking data from external source like maybe from file or database and processing and generating the report. But yesterday night, today night, there is some 24 hours gap is. Micro batch means batch to batch, the interval is very, very small. Maybe 5 seconds, maybe 10 seconds, like that. Got it. Such kind of processes are called streaming data processes. So simply you can say real-time analytics. There is another name. It's not exact real-time. It's a near real-time. Near real-time analytics. Suppose Amazon is interested for every 5 seconds, how many visitors are visiting this particular product page. They are selling many products. For every 5 seconds, what is the visitor count? They want it. Okay. So they don't this every day night. They want it in every 5 seconds. Understand the point? Such kind of analytics are called near real-time analytics. Another technical name for this is micro batch. That means Spark is supporting two types of process. One is batch process as usual. One more thing, micro batch process. Understand? And my second question, why Spark? Because to process the data, many weapons are there. Even SQL can process, your Python can process. Okay, there are many tools to process the data. Why you need Spark? Any answer, please?
Parallel processing.
Fast problem. Of course, parallel process. Final goal for the user is fast, speed. That means to process big data. Whenever you see the word big data, very big volume of data. Even though data volume is terabytes, multi-terabytes, the processing time will be in the minutes only. Got it? To process big data with high speed. So that is a major goal. And also here, Spark can process all varieties of data. What are the different varieties means?
Structure,
Now
structured
compare with
semi-structured.
SQL. What SQL can process? Structure. But lot data is messy. Lot data is unstructured, semi-structured, nested semi-structures. In this way, complex data is involved. Got it? So structured data, unstructured data, semi-structured data. You know the examples of these three categories. Examples for structured means your tables. Maybe normal tables or maybe delta tables. In our data lake, in our one lake, what you are using? Delta tables. Okay, storage format is delta. So Spark supports every format. Okay, tables, CSV files, or I mean delimited files. Delimited files example, CSV. These things comes under structured. Unstructured means our raw text. Example, customer reviews. Sorry. Image data,
Images, videos.
video, audio, anything. Okay, audio files, these things. And semi-structured data. Old
JSON.
legacy systems still they are using XML. Latest systems are using
JSON.
JSON. For example, data source is MongoDB, sir. When data is extracted into my one lake, what is the data format? Output format is in JSON. Suppose their OLTP system is MongoDB or Cassandra. Using data factory or connecting with them, extracting and dumping into your one lake. Now your storage part, the data shape is JSON data. Now Spark supports JSON, everything, even the big volume. Understand? And one more example, data source is Oracle. What is the output format?
Structured.
When I dump into the file, that will be into CSV format. CSV is a structure. Data source is Azure Data Lake Gen 2 or S3 or Google GCS. You want to analyze images content. You want to build a model based on the images. Now this is data format image only.
Unstructured data.
Image purely unstructured. So Spark is having no limitations about the data variable,
PNG,
whatever it may be. For us, that is a JPG file. For us, that is a picture. But internal, that is what 0 to 255 pixel matrix. Understand? Like that. So this is another beauty. First advantage is Spark and even though big volume of data, very high speed, supporting all varieties. Got it? But what Spark cannot do,
store data.
it cannot store the data. Temporarily, it stores the data into RAM. Once that job execution completed, data will be flushed out from the RAM. That means we need physical storage. In the place of physical storage in Microsoft Fabric, what we use?
Lakehouse.
Lakehouse.
One lake.
One lake. Okay, one lake is just a logical name. Internally, that is a lake house. Got it? So it reading from lake house and writing the results into lake house. Okay. So suppose so general style is what? Workflow style. Suppose source to
From
branch. Okay. Here I don't what I will use? Data factory pipelines I will use. Okay. And branch is the intermediate, the raw data. Branch to
silver.
silver. Here I use
Spark.
Spark to perform my transformations. Okay. Again, silver to final aggregated reports.
Gold.
Gold. Here also use
Spark.
Here, bronze means classification of data or what?
not like this. Treat that bronze as a raw data.
Okay.
Okay. What
After,
you have
okay.
access from the source, that is raw data.
Mhm.
After that, you are cleaning the data, perform
Yes.
transformations. Okay. So that is the mature data that is in silver. Final, the business analytics, data analytics, ready data. That is in
Mhm.
gold. Understand
Okay.
where data factory is coming, where Spark is coming.
Yes, yes.
Again, these results, I want to export into Snowflake. Now what I will use? Finally, gold to Snowflake. Here again I use data factory. Understand? Suppose client wants the data still to be in the gold only. He doesn't want it to other external systems. Now no need to use data factory here. But what are the results he got it here? He want to export this data into to some external systems out of the Microsoft. Then again we are using data factory. Understand? Where data factory is involving, where Spark is involving. You got clarity? Okay. Now, if you want to talk about the Spark key features. Number one, in-memory computing. Basically, when compared with the disk-based computing, the process is how the process is disk to virtual storage to RAM, RAM to CPU cache. In this, a lot of cycle is there internally. But if it is in-memory computing, your data partition will be loaded directly into the RAM. The cycling between RAM to CPU, only, RAM to processor. This kind of processing style is 100 times faster than traditional data processing. Okay, even though single mission, it is supporting in memory. That is, the in memory computing provokes speed. Got it. And second thing is MPP. What is MPP?
massive parallel.
Massive
Massive plus.
parallel process. Here, one particular thing we need to understand about this MPP. Let's talk about PP versus MPP. Here, PP means parallel process. MPP means massive parallel process. PP, the word PP talks single node level. That means parallel process by multi cores. Let's take your laptop. You have a processor. In your laptop, your processor has 4 cores. Understood? Suppose there is a data table. Let's say this table is sales. You have 400 rows for our easy understanding. Suppose one of the Spark SQL query I am giving. Select sum of amount from sales. What is the meaning expected by this query? That is total sales. How many records are there?
400.
So in normal data processing, what is the style? Forget about PP. In normal systems, if I run the same query in my database, what is the execution style?
Row by row, it will go in.
Row by row process.
Row by row.
Row by row process. If I have 400 rows means 400, that means first it will take
First row.
1000, 2000, think that these are the amounts. So first it will initiate one buffer in the RAM. Initial value 0. Take 1000 and add that 1000 to this 0. 1000. After that, come to the second row, add this 2000 to this 1000. 3000. In this way, record by record data processing will happen in normal systems. But in the parallel process, what is the style? Is if I run this query, if I have this one, data is divided into 4 partitions. Data divided into 4 partitions. Now, partition 1, what is the volume?
100.
100 rows, 1 to 100 rows. Partition 2, 101 to 200 rows. Okay. In this way, the data is divided to partitions. All these partitions separately loaded into RAM. Understand? Partition 1 processed by core 1. This is by core 2. Partition 3, this will be processed by core 3. Partition 4, this will be processed by core 4. This is a processing step. So previously think that 400 seconds is the time to process the data. Now what will be the time?
100 seconds.
100 seconds. That means 4 times speed increased or not? Time decreased means speed increased. Got it? But this entire parallel process happened at a single mission. Even though single mission, parallel process is possible. Got it? So same thing, if you talk about MPP, massive parallel process. This is parallel process at a cluster level. Parallel process at a cluster level. What is cluster here? In this case, cluster.
Bricks.
Group of machines.
A network of missions. A network of nodes act as, sir, visible మీకు? Act as single server. That is called
virtual server. Virtual machine.
It can be virtual, it can be physical. It can be virtual, it can be physical machine. Understand? A network of nodes act as a single server. That is called cluster here in this context. General as per dictionary, the meanings are different again for the cluster. Got it? So now think that imagine you have 4 node cluster. Now 4 missions I have. Of course, one master mission will be there. Master node will be there. Think that worker nodes, slave nodes are 4. Now what will happen? Partition 1 assigned to node 1. Similarly, partition 2, node 2. Partition 3,
Node 2.
node 3. Same style, partition 4, node 4. Now these 4 machines will be parallelly processing. Understand the point? For example, this is the case 1. Data has 4 partitions. Come to the case 2. Data has 10 partitions. But I have 4 nodes. This will be executed or not?
Pardon?
I have 10 partitions, but my cluster is having only 4 nodes.
Will execute.
Yes. What is the style?
Uh,
Maybe partition 1, 2, 3,
in node
4
1.
will be into node 1 of node 1, sorry, core 1, 2, 3, 4 of node 1. Okay. Let's say partition 4, 5 and 6. Core 1, core 4. There is no guarantee of the order
Yeah.
of
Node 2. It will take random.
there is some round robin algorithm internal.
Depends on
Hmm.
node.
That's it. Suppose think that already one core is processing some data, it won't assign another work to that core.
Yeah.
Which core is free in this moment, to that core the work will be assigned. Like this. Similarly, partition 7, 8 to core 3, core 4 of node 3. What are pending?
9, 10.
9, 10. Maybe core 1, core 2 of node 4. Understand? So that means what MPP is supporting here? Within the single node level, processing, parallel processing. Across cluster level also, parallel processing. That is the difference between normal parallel process and massive parallel process. Understand the point, sir? Sir, online team, are you clear about this point?
Yes, sir.
Sir, you just mentioned Spark is a serverless. So can I choose number of nodes within the cluster?
So here in Microsoft Fabric, you don't care it. Spark
Okay.
is not a serverless. Spark is a cluster. What Microsoft Fabric is providing, this is.
Okay.
It's providing
So basically, Spark is a open source. I can
Yes, is a
install it on
open
any.
source.
Okay, it is open source.
Is a Apache product.
Okay, got it.
Got it.
for, like you said, no, sir, for transforming data means data factory. So see,
We don't use transforming data factory. Data factory can do transformation.
but in Fabric we use notebooks for that.
In data factory also you can use it. But it supports only small volume of data.
It's not like big data.
Hmm.
Big data was Spark.
Yes. Main goal is this one. Why we are using Spark is this is to process of big volume. Even though big volume of data, within minutes you want results.
Yeah.
That is a
parallel processing.
Yes.
Parallel.
Got it.
Okay.
Without Spark also you can perform transformation
Yeah.
using your data factory because we have data flows Gen 2 feature. But data flow Gen 2 can process only structured and semi-structured. Limitation number 1.
It is on Excel.
Limitation number 1, it can process structured, semi-structured. Second thing, small volume.
Not massive one.
Suppose 5 terabyte data, 10 terabyte of data, if you give to the data factory, if you run some process now, maybe next week, Monday, you will see the result. Understand the point, sir? So in that case, for example, your bus time is by 8:30, sir. Seed allocation report to be generated at 8 p.m., sir. Because of big volume, if that process executed for 3 hours, 4 hours, understand the point, sir? Your vehicle time is 8:30, but report generated at 10:30. Speed demanded or not in this case? Understand the point? So wherever the speed is demanded, we use Spark. But in the cloud visions, when our Spark cluster came to the picture, automatically bill will be high. Understand? But in some cases, even though bill is high, speed is demanded. On that case only we use Spark. But there are some processes. Suppose your address updation, sir. Your address updation is the task. Morning to evening, I am getting a lot of address updation requests. Daily evening, I am running a batch process. By tomorrow morning, addresses have to be updated.
Yeah.
So in this case, speed is not demanded. At that moment, I can use data factor. Understand the point? Everything is scenario based. So what you are expecting, your expectation is to save the bill or to save the time. Understand? So if some client is asking, I want bill to be reduced, at the same time speed should be high, means there manually we apply some optimization techniques. Understand? The optimization technique, their developer skill is important. That is the data engineer skill is important. Got it? So final goal of the Spark is this one. Now, in the Spark, you have different components. One is Spark core. Second one is Spark SQL. Your 80% of work, 80 not 90% of work will be completed with this Spark SQL. Understand? And 3, Spark ML, machine learning. 4, Spark graphics. 5, another important, very important thing, Spark stream. Understand? Generally, this core is a foundational API here. So Spark engine. Okay. So Spark core means that is a Spark engine. And Spark SQL to process our structured data and also semi-structured data. To build our predictive models, Spark machine learning. With the help of machine learning, you can process unstructured data. Unstructured data examples already I told you. Raw text. Here we can use NLP. Understand? Image. To process the images, we need neural networks. Okay. Spark ML supports neural networks and deep neural networks. Got it. That means with help of Spark ML, all unstructured part can be done. Okay. With the Spark SQL, all structured data and semi-structured data can be. Understand? And graph data. To process the graph data. What is graph data? Those graphs line. Suppose in Facebook, I am adding you as a friend. Suppose I say I see your profile, I send a request. You accepted a request. Now one connection is created between you and me. I am a record, you are a record. Technically, I am a node, you are a node. One connection created between us. Suppose I have added Mr. Nikhil. Nikhil added Suresh. Suresh added Ramya. Okay. Who is Suresh to me? I repeat. I repeat. I added you. You added he. You added she. What is the relation between I and you? Friend. Not mutual friend. Friend. Relation between I and he. Friend of friend. Understand? Friend of friend. Who is the common friend? You. What is the relation between I and she? Friend of friend. Understand? So such kind of connections are called graph data. Understand? To process that kind of graph data, regular SQL queries will not work out. You need special graph algorithms. The Spark is giving you those libraries to process the graph data. Understand? So main purpose, this is core engine. It uses DAG internal. DAG means directed acyclic. Okay. So based on our code, depends on the dependency between the data objects. It designs execution plan. It designs execution plan. According to that, that plan will be in an optimized way. Automatically DAG designs that execution plan. Understand the point, sir? A small example, DAG style, sir. In Spark, the data objects are called RDDs, resilient distributed data sets. Forget about the code for now. Let's say the file is sales. This is RDD1. RDD2 second object. Sales2.txt. Look into the 3. RDD1 dot union of RDD2. Understand? Now RDD3 save as text. Suppose all branches data. This is the code you have given. First, which one to be executed, sir?
RDD1.
RDD1, a union RDD.
C.text file.
Both RDD1 and 2 is
Yes,
parallel.
parallelly.
After that, RDD3.
So now, what is a better optimized graph here? RDD1, RDD2, parallelly will be executed. At a time will be loaded into RAMs. Maybe RDD1, that means branch 1 data. Think that this is a branch, sales 2 is a branch 2 data. To read branch 1, there is no dependency with RDD2. To read RDD2, there is no dependency with RDD1. That's why both should be executed parallelly. After completion of both, then only RDD3 to be triggered.
Like if any one of the upper task fails, then that fails.
That's it. So that kind of execution plan will be decided by
That.
that.
The dependencies.
Suppose it is not the Spark program, sir. This is our Python program, treat it. What is the execution style? After completion of RDD1, then RDD2. Understand? If it is normal Python, not Spark Python. Understand the point? Traditional programming style, after statement by statement execution. After completion of this, second. Suppose first file is going to take 1 hour time. Another 1 hour it has to, second one thing has to be waited or not. Understand? But in the Spark, what is happening? The DAG is defining there is no dependency between RDD1 and RDD2. That's why both will be executed parallelly. 1 hour time saved, right? After completion of this, some other next step you are doing. After this, you are writing the results into your output. That execution plan, optimized execution plan, depends on the dependency between the objects will be created.
We
Got it?
can create the dependency of that also. In some scenario, if I want to execute one by one process, Then can we put the dependence?
No. You cannot cut the dependence or you cannot create the dependence. Here, RDD for RDD3 only there is a dependence. For RDD1, what is the input? A file, not other RDD. RDD2, what is the input? A file, not other RDD. But for RDD3, what is the input? RDD1 and RDD2. That means to execute RDD3, before that, these two things to be ready. But there is no dependency between 1 and 2. It depends on your given code, automatically DAG designs the flow. Understand the point? So that is what. So DAG, what it is doing? Defines execution plan. What is the plan? RDD1, RDD2 parallelly? If both successful, then RDD3. If RDD3 is successful, then only it is taking action. That action is write the results into text file or table or whatever depends on our given code.
The RDD full form.
Resilient distributed data sets. Understand the point? So this is what that thinks. That means a Spark core, one more statement. Uses RDD API. Understand?
So DAGs are created in Spark or DAGs. The DAG can be created in Spark.
First Spark. Airflow uses a DAG style of coding.
Airflow is mostly for monitoring the
No, orchestration. Airflow for orchestration. Suppose job 1 that is by Spark, job 2 that is by some other Google BigQuery. But this Spark cluster different, that Google BigQuery different. After completion of the Spark job only, Google BigQuery job should be executed. This kind of orchestration I am doing in Airflow.
Sir, I have one question, sir, regarding the ADF and Airflow.
Hmm.
Can I do like a large file also with the Airflow? Because ADF have limitation, right? Only for smaller semi-structure and
Remember one point, all of you. Airflow is not for data processing. Orchestration. Suppose my orchestration flow is like this. Spark job 1. Okay. After that, a Hive job 1.
different system.
After that, shell script 1. This is what mapping. Actually, job 1 created at where? Spark cluster. Hive job created at Hadoop cluster. Hive job created at Hadoop cluster. Shell script created at Linux.
Linux level, okay.
But my business plan is like this. After completion of job 1 only, Hive job to be triggered. After completion of Hive only, shell script to be executed.
Sir, basically Airflow is similar to step functions in AWS, right?
You can compare with that.
Got it.
Okay.
Airflow is similar to
Step functions in the AWS. In different clouds, different services are there. Don't worry about it. Airflow purpose is this one.
orchestration.
Orchestration. Finally, who is processing my data?
Spark.
After that, some other kind of process happens at Hadoop level. Some other thing at Linux.
Sir, in case of then Azure, like ADF is only data ingestion or both orchestration also it will use?
ADF can do orchestration. But ADF limitations within the Azure limit.
In Azure family.
Sir, are you clear?
Yes, yes.
ADF, data ingestion, that means data loading. Second thing, ADF can do
Orchestration.
Orchestration.
At Azure level only.
Two pipelines.
This, sir. Observe here a small comparison. ADF pipeline. That means a data factory pipeline.
Yeah.
Okay. Activity one. Copy data. What it is doing?
Copy data.
Guess it. Extracting, loading. After that, Databricks notebook one. What it is doing? Processing. Where is this? Within the Azure only. After that, some predictive model to be built. Azure,
Well,
Azure ML to predict the to build the predictive model. Understand? But I have a job of BigQuery. Copy data, extracting and loading, data cleaning and transformations, Databricks notebook. After that, building machine learning model. The predictions after by taking these predictions, next step I am expecting Google BigQuery. Is BigQuery job is part of Azure? No,
no.
that is not possible. In this place, solution
Airflow.
Airflow. It won't care about whether it is Azure family or GCP family or AWS family or on-premises family. It won't care. That means, in what way you can say Airflow? Based on this, try to give some better statement about that.
It was multi.
Can you say hybrid orchestration platform?
Yeah, that is.
Sir, online team?
Yes, heterogeneous orchestration.
Okay, hybrid.
Yeah.
Maybe same cloud or different cloud or on-premises.
All this different.
That's so here you are not trying to load data into BigQuery. If you want to load data into BigQuery, directly copy data is doing. But in BigQuery, there is some SQL script. I want to run that script. That is what I said job. So this kind of thing I cannot keep into ADF. So first what I need to do in this context, this entire pipeline I will execute at Azure Data Factory. After completion of that, I will inform to my other team. After that, that other team has to run BigQuery. Now what is the solution? Treat this as job one. Job two is BigQuery job. Job one is ADF job. Job two is BigQuery job. This is developed by me. This is developed by you. Let's marry them. Airflow job. In Airflow, what I am doing? First step, job one. Next step, job two. But job one is of Azure Data Factory. Job two is of BigQuery. For that purpose, because very soon we are going to already industry entered. Very soon we are going to enter into multi-cloud platforms. Understand? At the time, this Airflow will be useful or not?
Yes.
Like this. Sir, all of you clear about this point?
Yes, sir.
Yeah. So, little comeback. Up to now, clear what DAG is doing. So, look into the Spark core statement. It uses what? RDD API. So,
సార్ ఆర్డీడీ ఒకసారి తెలుగులో చెప్పారా సార్ ఎప్పుడు అది
yes, yes. First 1 minute. I will come to that one. This is RDD API.
ఓకే
Sir, in SQL, what are data objects? In SQL, what are data objects?
టేబుల్
Tables. Inka.
Schema, maybe.
Indexes.
Schema.
Schemas. All these are the data objects, right?
ఎస్ సార్
Similarly, in Spark core, the data objects are called RDD.
ఓకే
Sir, yesterday, are you available yesterday?
నో సార్ ఐ వాజ్ నాట్
Are you available yesterday?
Yeah.
Arey, you are available, man. I am not available. You are available. I am not available. Class happened or not?
No.
Remember my case too. I am available, but you are not available. Happened or not? Will
Yes.
happen, man. Only Nikhil did not attend. Remaining students attended. So class will be continued. Okay, all students are available, but Bharat not attended the session. Class will happen or not?
No.
Is it resilient?
Yeah.
That means our class is not resilient. Resilient means at any cost the process should be happening. At any cost, the process should happen. Understand the point, sir? So I'm coming to the RDD, simple discussion for today. Before bringing you into the lab. RDD full form is what?
It is
Resilient distributed data sets. So for namesake, that is RDD. Here what is the meaning of distributed data set? Distributed data set. Look at this. Look at this.
Multiple.
Data divided into partitions.
For execution, it divides into
First step, data divided into partitions.
partitions.
Partitions are loaded into not one mission.
Multiple.
Partitions are distributed across multiple nodes. That is a basic behavior. Up to now, clarified?
Yes, sir.
Okay. Sir, partition 1, observe this very carefully. Assigned to node 1. Nikhil sir, 1 minute. Partition 1 assigned to node 1. 2 assigned to node 2. 3 assigned to node 3. Partition 4 assigned to node 4, but during assigning into the node 4 down. Class should be continued or class should be cancelled.
Class should be continued.
Class should be continued. That means the process should be continued. Maybe immediately Spark master will engage other node for it.
Whichever node that time is free, will be engaged.
Only if Spark master down,
Then only
that means cluster down, then only you cannot run the process. Because of failure of any one of the node or any one of the intermediate step failure, the job execution should not be stopped. That work, the running work should be reassigned to some other node. That means automatic fault tolerance behavior. I repeat, automatic fault tolerance behavior. That is called resilient. Resilient distributed data set. Simply, if you want to define this, RDD is a collection of partitions. That means this is just a logical name. Internally, where data is in partitions. Understand? Is a collection of partitions. These partitions, runtime, loaded into RAMs of
nodes.
Spark worker nodes. Understand? I have 5 partitions into 5 different missions. Understand? Very big volume of data, I have 100 partitions into 100 different missions. That too not in the disk. Where is the place?
Ramps.
Because in-memory computing, right? In-memory computing. Because of in-memory computing, data directly loaded into these partitions directly loaded into RAM. Now you tell me, I have 1 terabyte of data. Query same, total sales I want. But for my table, the input volume is 1 terabyte. Really 1 terabyte, if you run by the normal database, it will take 1 hour time. If I execute the same query in the Spark, I get time in just 30 seconds.
And then distributes.
So what happens here? Run time. Not when data is in our table. When I run the job, Spark job, run time, that 1 terabyte data will be divided into
Multiple bundles.
partitions. How many partitions you want, you can decide. 100 partitions or 200 partitions or 400 partitions, depends on your cluster capacity. Understand the point, sir?
Yes, sir.
So these partitions, the runtime will be loaded into worker nodes. To find my total sales, all these 100 nodes will be running parallelly. Understand the point? So just within less than 1 minute, I will get the result. Same if you execute in other systems, it may cross 1 hour time. Got it? So that
Yes,
is
sir.
what the meaning of RDD. Spark understands RDD soon. But understanding RDD, Spark understand RDD. But I am comfortable with SQL. I am comfortable with some other API. But Spark understands only RDD. That's why next level components. On top of this Spark core, what are the remaining components? Spark SQL, Spark machine learning, Spark GraphX, Spark streaming. These are the next level components. Okay. So one more little thing we need to understand about this one. How fault tolerance things, that means how parallel process will happen. What is the execution style of data flow? Then we can start this execution into the Fabric notebooks. First, you confirm me. Purpose of Spark, clear or not?
Yes, sir.
Yes, sir.
Where data factory and where Spark here in this case, especially in Microsoft Fabric case, where you will use data factory, where you will use this.
Spark.
That means Spark means Fabric notebook.
The data factory where we have only structured and semi-structured.
No, sir. Again, you are confusing.
Volume of data.
Blindly use data factory for
That's load.
extraction, loading. What is our style, sir? ETL or ELT?
EL,
In big data, what is the style? ETL
ELT.
or ELT? ELT. Extract,
Load.
load, transform. Here, better way. For extracting and loading purpose, use
Ready.
data factory. For transformations, use
Fabric.
Understand? If I go with the Spark for data processing, what benefits I am getting? High speed. One is high speed. Second benefit,
Parallel.
variety. Structured, unstructured, semi-structured, anything. So I don't have any limitations. Even additional benefit of the Spark, streaming. Spark streaming component is there. Understood? Okay. So tomorrow we will understand about remaining components. Then we will start coding. Right? And also few more thing about the RDD we need to discuss. The data flow execution style is important.
Okay.
So keep these notes with you. After that, all the discussions, whatever the previous session discussions, everything I will keep into one single document. Okay.
Can you ping this link, sir?
Yeah, I just post into chats. And we have session at 8:45 for the machine learning, and please give me 5 minutes break.
Yes, sir. Thank you.
I posted in Zoom chat some notes.
Yeah.
Later, I will update you into the groups. And who are not in the group also, just please ping me. Like, I will add you. I will ask Tejaswini and Sri Lanka teams to add you into the groups.
So, sir, do we have a different groups for ML and this Azure?
Yes, sir.
Okay.
I will guide you, sir. I will interact with you after that.
Okay. Fine.
While I will be free, just ping me. I will add you into the group.
Sure.
Thank you, sir.
Thank you, sir.
Yeah, bye.
Thank you, sir.